Hi, this is the course about validation, and this is the final module of part 2 of this course, where we discuss the topic of validation in general and how it fits into domain-driven design. In this module, we will talk about how to define explicit errors in the application and how to standardize the API output. We will also discuss the so-called DDD trilemma. The error definitions that we currently have work reasonably well in small and medium-sized projects. In more complex projects, however, they lead to some issues. First of all, returning a string is not a reliable way to represent an error. If you develop an API, then the actual error message should be the responsibility of the client that consumes your API. And even if you decide to handle this responsibility in the API itself, it should be handled by the application layer, not the domain layer. You might want to localize error messages, translate them into various languages, depending on the user settings. You may also want to map your errors to different HTTP response codes. For example, some of your errors may need to be returned with a 404 HTTP code, some with 400, and so on. This is all the responsibility of the application layer. How to fix this? The best way is to explicitly define each error your application may return. As an added bonus, this will allow you to more easily debug your system because you will be able to quickly find potential sources of any error. Let's see how this can be done. This is our email value object with a string error messages. The result class we are using has an overload where we can specify the type of the error. By default, it's set to string. We can change it to a custom error class. This class doesn't yet exist, so let's create it. The error itself is going to be a value object, meaning that errors will not have an identity and can be used interchangeably. Each error will have two fields, a code and a message. Notice that in the getEqualityComponents method, I'm returning only the code field. That's because the code is going to be part of the contract between the API and its clients. Once published, error codes should not be changed. Error messages, on the other hand, are just for informational purposes, so that we can specify some additional information for debugging. Ideally, the client should not show that message to the end user, and instead should map their own messages onto these error codes. Also notice that the code could also be of type integer. I personally find strings easier to work with though, because you can assign them meaningful descriptors. I'm also adding a constructor. This constructor is internal to indicate that these errors should not be instantiated arbitrarily, and instead should be taken from a predefined set of errors. We can define that set using another class, errors. This class will enumerate all possible errors in our application. Such explicitness is useful because it gives you visibility into what errors there are in your application and in what circumstances they may be returned, which is something you could never achieve with plain strings. So what errors should go here? Well, we just need to convert all our strings into error instances. It's also a good idea to subdivide your errors into groups. These particular errors are usually repeated among lots of value objects, so we can put them into a general group. Not found, value is invalid, value is required. We can also make the ID field optional, so that we don't have to specify it if we don't want to. An error for invalid length. Here we also have an optional parameter specifying which field we're talking about. That's going to be useful for the address entity. We could also pass some additional details here, like the maximum and the minimum allowed length. Aside from the general group, we will also have a group for student-specific errors, such as email is taken and invalid state. This second one could also belong to a separate group if it's going to be used by something else other than the student address, but for now we're only using it in the student entity. Note that if you don't have a lot of errors, you can skip this division into groups. You can also introduce more nested groups to split your errors even more gradually if needed. Alright, we can now return these errors instead of the plain strings. This one is going to be from errors.general. I'm replacing value is too long by a more generic invalid length. Value is invalid. And I also need to fix the success method to specify the new error type. Notice how our calls to the result class has become quite verbose after this refactoring. Thankfully though, we can just return errors themselves. The result class supports implicit conversions, and it will convert our errors into failed result instances automatically. Same for the success case. Much better. Let's do the same in the state value object. Replacing value is required, these two, and the success case. Finally, we need to change the address entity. This is where we will pass a label to the invalid length error. This label is needed to differentiate between different fields of the address value object. Note that if we were using separate value objects for each address property, like we did with the state, then this differentiation would not be needed, because Fluent Validation would be able to specify the full path to the field with error. Also note that these labels have nothing to do with the field names in the data contract. The address entity resides in the domain layer and shouldn't know anything about the data contracts the application layer uses. That's also why we're not passing the request class to the create method. Finally, we need to modify our extension methods so that they work with factory methods of the correct signature. Adding the error here too. And I will return the error code for now. We will come back to this point later. Same for the mustBeEntity extension method. And I need to delete this code. The empty string case is currently handled by the value object itself. No need to exclude it here. Let's run the application and make sure everything is working. If I remove the state, then the API returns the code of one of our errors. If I change the state to an incorrect one, you can see it now shows us another error. And if I send the correct state, then the student is registered successfully. Very good.